The question we are asked is to determine how many of these molecules are polar. The steps we are going to take is first, draw the Lewis structure. Second, identify bond dipoles and partial charges by using differences in electronegativities. Then we are going to identify net molecular dipoles based on molecular geometries. So we'll start off by drawing the Lewis structure for SO3. That is 24 valence electrons. We start by making octets in the outer atoms. Now we are counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All 24 are used. We used to make a double bond here to make sulfur follow the octet rule. And we're going to have a partial negative charge here since oxygen is more electronegative. Partial negative with dipoles going to oxygen. So our molecular geometry is trigonal planar since we have 3 domains and 0 non-bonding electrons. So trigonal planar looks like this. All 3 domains are the same and each dipole cancels. So no net dipole, non-polar. So SO is non-polar. O, oxygen difluoride, has 20 valence electrons. So we draw the Lewis structure. Fluorine is more negative, electronegative, so it's going to have partial negative charge. Oxygen, partial positive. 4 domains with 2 non-bonding pairs give us a bent molecular geometry. And all 4 domains are not the same. Therefore, we have a net dipole going down here. So it is polar. Right, polar. So again, we draw the Lewis structure for BeCl. Start by filling the outer. That was my mistake. So we have a partial positive and a partial negative on the chlorines since they're more electronegative. That gives us 2 domains with 0 non-bonding pairs. So we get linear molecular geometry. Dipoles shooting out here. to the chlorines. We have two same domains, so the dipoles cancel. No net dipole. And nonpolar. So that gives us BeCl2, nonpolar. CCl4. Again, step one, draw the Lewis structure. Fill out the outer atoms. Chlorine's more electronegative. So we have negative charges on all the chlorines with dipoles shooting out towards them. And we have 4 domains with 0 non-bonding. So we get tetrahedral. Molecular geometry. Try to draw this in a 3D fashion. And all 4 of our domains are the same. Therefore, all of our dipoles cancel. And then that leaves us with a non-polar molecule. No net dipole. Non-polar. Okay, next we have O3. Draw the Lewis structure. Which is this. And our molecular geometry would be 3 domains with 1 non-bonding. So it is bent. And since this non-bonding pair gives us a partial positive, and here we have a partial negative charge, and all the 3 domains are not the same, so non-equal domains. Non-equal domains gives us a polar molecule. So ozone is polar. So to answer the beginning question, which of these molecules is polar? The answer would be OF2 and O3. Thank you. Oh, some common mistakes. Common mistakes. Wrong Lewis structure. Wrong geometry. And electronegativity calculations. Thank you for tuning in. Catch you next week.